Hello students, in the last video we discussed hybridization of the organic compounds. Now I want to explain how to identify the hybrid orbitals and unhybrid orbitals in a given organic molecules. So hybrid and unhybrid orbitals. So the first example CH4 molecule. The CH4 molecule is called methane. Methane. Now the central atom here carbon only. Central atom is carbon. So carbon atomic number 6. The electronic configuration of this carbon is 1s2, 2s2, 2p2. Now this one is the ground state electronic configuration of the carbon. In the ground state, the s orbital represented here, orbital representation is this one. This one is the p orbital representation. So in this, majorly the number of electrons present, it has 1 electron, here 1 electron, here also 1, but S has how many 2. So 2s2 2p2 is the ground state electronic configuration of the given carbon. Now this carbon has how many hydrogen atoms here? Okay, here 4 hydrogen atoms. So 4 hydrogens means 4 unpaired electrons required in hybridization. So generally in the first excited state, so carbon involving in the first excited state. Now one electron might jump from 2s to 2p orbital. Now the electronic configuration is 2s1, 2p3. This one is the electronic configuration of carbon in the first excited state. So in this first excited state of this one, the orbital representation is here 1, here 3 orbitals like this. Now it has 1 electron, 2, 3, 4. Totally 4 unpaired electrons are present in the first excited state. So after that, so this one involving in the hybridization. These orbitals are called atomic orbitals. These are called atomic orbitals. So after involving in the hybridization, now how many hybrid orbitals are formed? 1, 2, 3, 4. Each hybrid orbital has 4 unpaired electrons. Totally 4 unpaired electrons present in the hybrid orbitals. Each one is the hybrid orbital. Each hybrid orbital in this, now it is sp3 hybrid. This one also sp3 hybrid. This one also sp3. This one also sp3 hybrid. Totally how many hybrid orbitals? 4 hybrid orbitals. 4 sp3 hybrid orbitals. Okay, ma? These are the 4 hybrid orbitals formed in carbon. Central atom only forms hybrid orbitals. Remember this. Central atom only forms hybrid orbitals. What about the remaining hydrogen atoms? The remaining 4 hydrogen atoms, these are the s orbitals. 4 hydrogen atoms here contains 4 s orbitals. These 4 s orbitals here unhybrid. Okay, these are the unhybrid orbitals. 4 unhybrid orbitals. Okay, now 4 unhybrid orbitals, 4 hybrid orbitals. So generally one carbon, the structure of the carbon with the hybrid orbitals. This is the one hybrid, second one, third, fourth one. So these are the hybrid orbitals of which one? Carbon. Carbon only here formed sp3 hybrid orbitals. sp3, 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 sp3. The remaining s orbitals of hydrogen spherical shape. It is s orbital. It is also s orbital, s orbital. Totally here s orbital, s orbital, s and s. These are the sp3. It is the s orbital. Okay. Now this is the sp3. It is a s orbital. Totally here, how many sigma bonds are formed? 1, 2, 3, 4. Now totally 4 sigma sp3 s bonds. These are the totally 4 sigma sp3 s bonds. So by using this one, carbon here formed sp3 hybrid orbitals 4. Now maximum they will ask ratio of the hybrid and unhybrid orbitals. So what is the ratio of hybrid and unhybrid orbitals? Hybrid orbitals by unhybrid orbitals. Number of hybrid orbitals here 4. These are the 4. Right here 4 by unhybrid orbitals here again 4 s orbitals equal to 4 unhybrid. So 4 by 4. Both cancel with each other. Now the ratio is 1:1 ratio. Hybrid and unhybrid orbitals in CH4 molecule is 1:1 ratio. This is the ratio of hybrid and unhybrid and hybrid and unhybrid orbitals identification. The next, another example, CH2 double bond CH2. So this molecule name is called ethylene molecule. This one is ethylene molecule, or other name is ethene also. Okay, other name is ethene. Ethene or ethylene molecule. In this, how many carbon atoms are present here? 2 carbon atoms. So 2 carbon atoms generally it involving in the hybridization. 2 carbon atoms. This one also central atom. This one also central atom. How many central atoms are here? 2 central atoms. Now each carbon in this given condition. Now the structural representation H, C, another hydrogen, double bond C, H, H. Here, one carbon has how many bonds? That is count first. Count the number of bonds. 1, 2, 3, 4. 4 bonds present. So 4 bonds means how many unpaired electrons required? 4 unpaired electrons required. So now count here also 1, 2, 3, 4. Again 4. This carbon also required 4. This one also required 4 unpaired electrons. Just now we discussed here carbon in the ground state, 2 unpaired electrons, 1 lone pair. But in the first excited state, it has 4 unpaired electrons. Same. Here also, this one, in the first excited state of carbon. First excited state of carbon, it is involving in the hybridization. Same, 2s1, 2p3. Now, s orbital representation here 1, p orbital here 3 orbitals. 1, 2, 3, 4. But calculate here number of sigma bonds. How many present? 1, 2, 3 only. Here also 1, 2, 3. 1 is the pi bond. So 1 is the s orbital. Remaining 2 p orbitals only involving in the hybridization. How many are involving in this? Totally 1 s orbital, that is a 2s orbital. The remaining 2p orbitals. Totally 3 only involving in the hybridization. Now these orbitals called atomic orbitals. Totally how many involving in this? 3 atomic orbitals only involving in the hybridization. Okay, that is also important. Based on the number of sigma. Here 1, 2, 3. 1 is a pi bond. So 3 sigma bonds means 3 atomic orbitals only involves. So in hybridization, how many hybrid orbitals might forms? 3 hybrid orbitals. It is also important. So here 3 atomic orbitals involving in the hybridization to form 3 hybrid orbitals. Okay, next term. Now coming to the same condition. After that, the 3 orbitals, atomic orbitals, one is the unhybrid. These are the hybrid orbitals, that each hybrid orbital has one electron. Here unhybrid also has one electron. Okay, in this, these hybrid orbitals are called sp2, sp2, sp2. Three sp2 hybrid orbitals. One is normal p orbital. This one, p orbital. This p orbital is unhybrid. It is unhybrid orbital. These all are the three hybrid orbitals. Okay, ma. These are the three hybrid orbitals. Here, this one is unhybrid orbital. In this condition, ma, three sp2 hybrid orbitals, one p orbital. It is only for one carbon atom. But in ethylene molecule, how many present? Two carbon atoms present. Okay, ma, two carbon atoms. Now, the orbital representation, ma, orbital graphical representation, two carbon atoms. Now, each carbon formed here, how many sp2? Three sp2 hybrid orbitals. This is the one sp2. This carbon also my sp2. Okay. Next, another one. This is the one sp2. Another sp2. 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 Identify in this total number of hybrid orbitals. That is only important in this. Total number of hybrid. How many ma? sp2, 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 this one, this one. Totally ma 6 here. So hybrid orbitals equal to 6. This is the hybrid orbital condition. Ma 1 carbon 3 means 2 carbon atoms. 2 into 3 6. Okay now. 2 into 3 6 only. Then next, this carbon has one p orbital. It is unhybrid. That unhybrid orbital representation, it is a dumbbell shape only ma. This one. This carbon also has. Okay ma. Dumbbell shape p orbitals. Each carbon has one unhybrid orbital. Now in this, the unhybrid orbital, it is axis only, but this other color is represented here. This one perpendicular to this axis. Now these two partially overlapping takes place. This is the pi bond formation. Okay ma. Here this is the one p orbital. This is another p orbital. One pi bond. Now remaining hydrogen atoms are totally 4 hydrogens. Now hydrogen atom here, one s orbital. This is the another, this one and this one. Now hybrid orbitals sigma. Here how many hydrogens present? 4. So unhybrid orbitals equal to 4 hydrogens plus 1 pi bond also. 1 pi bond. 1 pi bond means how many unhybrid orbitals? 2. So right here 4 hydrogens plus 1 pi bond equal to 2 unhybrid orbitals. Totally 6 unhybrid orbitals. 6 hybrid, 6 unhybrid. This one identification, 6 hybrid and 6 unhybrid orbitals. So remember this point 1 pi bond is equal to always 1 pi bond is equal to 2 unhybrid orbitals. Remember this. It is very, very important. Next, this one C2 C2H4 molecule. Next, if you observe in the another condition, CH triple bond CH molecule. The name of this one is called acetylene. What is the name of acetylene molecule? Or other name is ethine. Other name is ethine molecule. Ethine. So in this number of carbon atoms again 2. So identify the number of sigma bonds in this H, C, triple bond C, H. So number of sigma bonds in the given compound is 1, 2. Here also 1, 2. The remaining 2 are the pi bonds. How many total number of total number of bonds means 4 only. It required 4 unpaired electrons. But based on the number of sigma bonds, 2 only involving in the hybridization. That is the meaning. Only 2 involving in the hybridization in the first excited state of carbon. So 2s, 1, 2p3. In this 1 electron, here 3. Now these 2 only involving in the hybridization. Okay. Now these 2 only forms hybrid orbitals. How many hybrid here? 2 hybrid. How many unhybrid? 2 unhybrid. So in this given condition, here 1 electron, here 1 electron, here and here 4 electrons. But these 2 only hybrid orbitals. So these 2 hybrid, one is sp, this one also sp. But these 2 are p orbitals. These 2 p orbitals only. This is also p orbital. This one also p orbital. 2 p unhybrid orbitals. These 2 are hybrid. What about these 2 unhybrid orbitals? Okay, ma. In this, 1 carbon only formed here, 2 hybrid, 2 unhybrid. It is also important. 1 carbon only. Now, so based on the condition, so we can draw the structure orbital representation like acetylene molecule, C, right? How many sigma? How many sp hybrid orbitals? 2. This is the one hybrid. This is the another carbon. This one hybrid. This one is hybrid. Totally, how many hybrid in this? The total number of hybrid orbitals. sp 1, 2. It is also sp. It is also sp. Totally 4 hybrid orbitals. Okay, hybrid orbitals equal to 4. Clear. Next, right here. Here hybrid orbitals equal to 4. Okay, in acetylene molecule. Next, each carbon has how many unhybrid orbitals? It is one unhybrid. This is also another unhybrid. Now draw like this. This is the one unhybrid. This is the another unhybrid. Same like this one also carbon. Okay, it is also one unhybrid. P dumbbell shape only. This is the another dumbbell shape of the molecule. In these two, now how many hydrogen atoms? 2 hydrogen atoms. This one forming sigma bond. Here also this one forming here 1 sigma. That means sps sigma bond. It is sp sigma bond. It is sps sigma bond. Then if you observe in this case, this orbital and this orbital both partially overlapping with each other. This orbital and this orbital both partially overlapping with each other. Again, these two. The total number of pi bonds in this 1, here 2. Okay, total number of pi bonds 2. So in HC triple bond CH, how to calculate the number of sigma and pi bonds? So here 1, 2, 3 sigma bonds. Okay, number of sigma bonds equal to 3. But hybrid orbitals 4. 1, 2, 3, 4 hybrid orbitals. Unhybrid orbitals here. How to calculate that unhybrid? Unhybrid, each one contains here 1, 2, 3, 4, 5, 6. Now unhybrid orbitals equal to 6. Hybrid orbitals 4, unhybrid orbitals 6. But number of sigma bonds here, kind of sigma bonds present sigma sp bond equal to 1. Okay, middle one. Next, this one is sigma s kind of bond, it is 2. These are the 2 bonds. Next, number of pi bonds. number of pi bonds, pi pp bonds equal to 2. Ma, it is also p orbital, this one also p orbital, pp bond. How many ma totally? 2. So in this case, number of sigma and pi bonds, hybrid and unhybrid orbitals ma formation. Now coming to this condition ma, types of sigma bonds in ethylene molecule. Now this one is sigma sp2 sigma bond equal to 1 ma. Next, sigma sp2s bonds equal to totally 1, 2, 3, 4. Totally 4. Next, pi bonds ma, number of pi bonds equal to pi, pp bond equal to 1. Or we can also write this one ma, p pi bond equal to 1. Here also we can write same, p pi bonds equal to 2. So ma, these are the identify and calculation of number of sigma and pi bonds and hybrid and unhybrid orbitals. And another one more calculation of sigma and pi bonds, hybrid and unhybrid orbitals ratios ma, the direct molecules. How to identify the without drawing this orbitals representations everything ma. Now I will explain 2 to 3 examples, right? Right. The first example ma. So like this kind of molecules only they will ask. Like this. Identify the hybrid orbitals, unhybrid orbitals, number of sigma bonds, number of pi bonds. Okay, first one. How to identify that first? Okay, now in this, first identify the hybridization of the first carbon. How many are here present? Here this terminal carbon atom given means it has 3 hydrogen atoms. 3 hydrogen atoms means 3 bonds plus this is the bond. It is a sp3 hybridized carbon. Next, second carbon bond. This one has 1 hydrogen. 1 hydrogen means consider the sigma bonds only. 1, 2, 3. This is a pi bond. So it is a sp2 hybridized carbon. Next, coming to this one again. It also has 1 hydrogen. 1, 2, 3 bonds. One is a pi bond. So this one also sp2 hybridized carbon. Now coming to this one, this carbon has 2 hydrogens, 2 bonds, 2 hydrogens means totally 4. 4 means hybridization is sp3. Okay, sp3. Next, if you identify in this it has 1 hydrogen atom means this carbon is sp2 hybridization. This terminal carbon atom has a double bond means it has 2 hydrogens. One is the pi bond, another one is sigma, 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 totally 3. So again this carbon is sp2. Now, how to identify the hybrid orbitals directly by using this? First write number of sp3 hybrid orbitals, 2 sp3 hybrid orbitals. Okay, 2 sp3 hybrid orbitals. That means a carbon, 2 hybrid carbon atoms. Plus how many sp2? 1, 2, 3, 4. 4 sp2 carbon atoms. Plus sp not there. Then directly write 2 sp3 means each carbon forms 4 sp3 means 4 hybrid. 2 into 4, 8 hybrid orbitals. Next, sp2 means 1 plus 2, 3. 3 into 4, 12. Total hybrid orbitals 20 hybrid orbitals. Next, unhybrid orbitals. Count the number of hydrogen atoms here 3, 4, 5, 6, 7, 8, 9, 10. So 10 hydrogens atoms plus next how many pi bonds are present? 2 pi bonds. So 2 pi bonds. Totally 2 pi 1 pi bond equal to 2 unhybrid. 2 into 2 4. 10 plus 4 is equal to 14 unhybrid orbitals. This one is the calculation of hybrid and unhybridization. And how to calculate the number of sigma bonds. This one also important. So number of sigma bonds means first identify the formula. First I will give the formula only, right? for sigma and pi bond calculations. Number of sigma bonds is equal to total elements minus 1. Use this formula, you will get number of sigma bonds in a given any kind of molecule might is. Okay, this is the formula, number of sigma bonds. Okay, ma, this is the formula only. One just identify number of carbon atoms. 1, 2, 3, 4, 5, 6 carbon atoms. That right is C6. Next to hydrogens. Just now we counted 10. So formula is C6H10. My total number of elements in the given molecule 6 plus 10, 16. So number of sigma bonds equal to 16 minus 1. You will get 15 sigma bonds. This is the formula. Number of sigma bonds calculation. Clear on this one. Number of sigma bonds equal to 15. Total elements minus 1. You will get always sigma bonds. Next, number of pi bonds. So pi bonds means in the given molecule we can identify directly this one. 2 pi bonds here given. But like this compounds, how to identify? So that formula 2n plus 2 minus number of hydrogens by 2. You will get a number of pi bonds. So apply here. N means carbon atoms only. Number of carbon atoms. Where N is equal to number of carbon atoms. Now, N equal to 6, 2 6 12 plus 2, 14 minus number of hydrogens here 10 given. So 14 minus 10 by 2. Now 14 minus 10 means 4. 4 by 2, you will get 2. How many number of pi bonds? Here 1, here 1, 2 pi bonds. So by using this formula, we can identify the and calculate the number of sigma and pi bonds very easily. Okay, ma. So next, another molecule. For this kind of molecule, ma, first directly write here hydrogens 2, here 1, here 2, here also 1, here also 1, here 2 hydrogens, here 1 hydrogen, here 2 hydrogens. Okay, ma. So in this, number of carbons count 1, 2, 3, 4, 5, 6, 7, 8. C8 hydrogens 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. C8 H12. Now calculate the hybridization in this given. It is sp2. For hybrid orbitals, count the sp2. 1, 2 sp2, 3, 4, 5, 6. 6 sp2. So sp2 means 3. 6 into 3 plus sp3. Here 1 sp3. Here also 1 sp3. Totally 2. So 2 into each sp3 forms 4 hybrid. Now 6 3s are 18 plus 2 4s are 8. So totally 26 hybrid orbitals are present in the given molecule. Next, unhybrid orbitals. Total number of hydrogens here 12. 12 hydrogens plus number of pi bonds 1, 2, 3 given. 3 means 3 2 is 6. 3 2 is 6. So now totally here 12 plus 6 is equal to 18 unhybrid orbitals. So number of sigma bonds calculation 8 plus 12 20. 20 minus 1 you will get 19 sigma bonds. Next, number of pi bonds. Already here clearly given 3 pi bonds only, but by using this formula 8 is the carbon. 2 into 8. 16 plus 2. 18. 18 minus 12 by 2. 18 minus 12 ma 6 by 2 will get 3 sigma 3 pi bonds. Okay, so this one is the calculation of sigma and pi bonds and hybrid and unhybrid orbitals. So this concept also very important. Sometimes they will ask ratios of the hybrid and unhybrid orbitals, sigma and pi bonds also. So that's why here by using this you will get easily the number of sigma and pi bonds, hybrid and unhybrid orbitals. Now, in this case, just cross verify the number of sigma bonds here. Okay, whether this formula applicable or not. First, hydrogen and carbon mate is the 1 sigma, 2, here 3, 4, 5, 6, 7, 8, 9, here 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So, number of sigma bonds 19. So, this formula is applicable in this. Okay, this formula applicable sigma. Pi bonds means already it is satisfied. So, by using this formula, we can calculate the sigma and pi bonds. But this formulas too, these are applicable for only open chain compounds. Open chain compounds only. Okay, open chain compounds, but not the cyclic rings. Okay. Next, these are the sigma and pi bond calculations. Next, another video we will discuss another topics, that is types of the carbon atoms. Okay, types of the carbon atoms, and after that nomenclature also I will explain. Please subscribe and watch my videos and share to your friends. Thank you.